Well, Roberto, if you notice, speaking of technologies, he's the one photo in the program that is black and white, so I'm not sure if he still has a black and white TV at home. We asked him at least send a selfie in color, but he actually looks, in other words, I couldn't find anything on Facebook about him. But he is, like myself, he lives in Seattle now. He moved from California to Seattle. I'm happy being in California, enjoyed Seattle, but he's doing his best to keep things hopping up in Seattle, and really amazing background and talking about combustion engines, I believe. And where is Roberto in the audience? Okay, I'm looking right at you. Okay. Come on up to the stage, and you can tell a funny anecdote if you'd like.
Thank you, Richard. No funny stories, I'm sorry, but and no pizza either. But when I come to Bakersfield and Kern County, and I hear about the development of renewable energy, it's quite amazing. It's astounding what has been done here, and ideally, we would like to have 100% of the energy supply being done by renewables. But the reality is that fossil fuels play a very important role in the supply of energy today, and it's projected that fossil fuels will continue playing a very important role in the supply of energy in the future. So, but when we burn fossil fuels, one of the primary concerns is that we have to do it in an environmentally responsible way. So it's important that as we move forward and we do combustion of fossil fuels, that we develop technology that can deliver the environmental performance that the regulators are asking for. My company is ClearSign Combustion Corporation. We are based in Seattle, and we're developing some combustion technology that promises to deliver the best environmental performance of any other technology burning fossil fuels. And it has some other benefits as well that I will discuss in just a second. Richard? There we go. So Kevin talked quite a bit about the energy industry in Kern County. He did a terrific job highlighting how important it is for the county. The kind of combustion technology that we're developing, we're primarily addressing right now two separate areas, two market segments that are very important for the energy industry. Oil production, and then we are also targeting refineries. So in refineries, is one of the most energy-intensive industries in the United States. A lot of burning of fossil fuels, and our technology, we're addressing that technology, and we have a lot of interest here in the Kern County area about our technology. We're currently working in oil production with ERA. As a matter of fact, we're doing some testing this week. We just started doing some testing of our technology this week, and we're in discussions with several different oil refineries here as well, to introduce our technology into their operations. What did you do, Eileen? Oh, there we go. So when we look about environmental regulations, for control of pollution, air pollution, it goes back to 1970s with the implementation of the Clean Air Act. There have been a couple of amendments. The Clean Air Act addresses Title I, which is the part of the Clean Air Act amendment that addresses smog. Typically, we talk about smog is ground-based ozone. And according to the EPA, smog is the most widespread and persistent urban air pollution problem. Now, California has some of the strictest regulations, air pollution regulations in the country, and San Joaquin Valley is right there. So it's very important to look at ways how we can control pollution of air. So when we talk about smog, the formation of smog typically comes from nitrogen oxides that are typically generated in a combustion process. They're a function of temperature, so the higher the temperature, the more nitrogen oxides, we call it NOx. And then also volatile organic compounds. Volatile organic compounds are in the environment. When you go fill up your car, if you drip a little bit of gasoline, this gasoline evaporates, and then you have volatile organic compounds in the environment. But not only do we have VOCs from that perspective, but there are also some naturally forming conditions for VOCs. Like, for example, cows are a big contributor of VOCs as well. When we talk about NOx formation, which is a product of combustion, there's a couple of sources of NOx. We have what we call the mobile sources, so your cars, trucks, airplanes, and then we have the stationary sources, which would be power plants, all refineries, water heaters at your home, equipment of that nature. So typically, so you have NOx in the environment, you have VOC in the environment, you have sunlight, and then we form what is called photochemical smog. And photochemical smog is not desirable because there's a correlation between respiratory illnesses and smog concentration in the environment. So we have all seen these pictures. I had the opportunity to travel to China a couple of times this year, and this is essentially what you see. The smog is a brown cloud in the air, and then you see people wearing masks to protect themselves. Now, of course, smog is not something that is exclusive to China, but typically any kind of urban area, you're going to encounter smog conditions. And you guys may remember when I first came to the US as a foreign student at UCLA, we couldn't see the mountains in the LA basin. It used to look like this, and people actually used to can the smog and sell it. But there's been tremendous progress in that regard, so the environmental regulations are working. And of course, not all smog is bad. So it's the mentality of the entrepreneur. So when we look at industrial pollution control, of course, it's important to have industrial pollution control. We want to control our environment. However, when we look at the regulations and the kind of equipment that has to be implemented, it represents a huge economic burden for industry, also for people who buy automobiles, so all of us who buy automobiles. And so you have the capital expenditure of buying the equipment that is going to be controlling your NOx, but then also there's some performance issues that are detrimental. Such as in some instances you have to consume more fuel. In some other instances, your production may suffer. So just think about your catalytic converter in your car. When you put the catalytic converter, you lose power. You have to use a little bit more fuel. And of course, that impacts the competitive position of American industry on a worldwide basis in the global economy. And in some instances, this has forced industry in California to leave the state. So if we look at conventional combustion systems, and I'm showing you a burner in a refinery process heater, where you see a burner, you see a flame. The flame is very long. You have the tubes around it where you're processing the oil to make it into gasoline. And it's a flame that becomes very long, and most of the transfer is taking place by the radiation coming from the gases itself. The technology that we have developed, we call it Duplex. And in Duplex Technology, essentially what we do, we sustain the combustion within a porous ceramic matrix. So the combustion, instead of taking place along a very long flame, we actually confine it within this porous ceramic matrix. The ceramic matrix heats up and becomes a very good radiator of energy. But also, by doing this, we can also quench the actual temperature of the combustion process and control the NOx emissions to levels that nobody has ever experienced before. This is just a picture of what this poroceramic matrix looks like in one of our research and development furnaces. And then if we see here the performance of NOx, we can see on the green line that we start the process before we start operating with Duplex. The NOx performance was somewhere around 100 to 120 parts per million, which is completely unacceptable. The regulations today, depending on the process, are going to be anywhere between about 6 parts per million up to maybe 35, 40 parts per million. And when we apply our Duplex technology, it takes a couple of minutes for the NOx to go down. And in this graph, you can see that the NOx is operating around 5 parts per million. We have actually demonstrated NOx performance below 5 parts per million in the recent past. Now, the benefit also of our technology is not only does it control the NOx, but we can deliver energy more effectively. So I mentioned to you that with a typical burner, you are radiating from the gases themselves. So if you look at the red line in this graph, that's the typical radiation that you would have. It has very important spectral characteristics in the gas radiation. But the way how we radiate what we call a black body radiation. So when you try to calculate the amount of energy that is being delivered, you calculate the area under the curves. So you can see if you calculate the area under the red line and compare that to the area under the dotted line, the blue line, you can see that the amount of radiation that we are supplying, energy transfer to the process, is going to be considerably larger with our technology. So I mentioned we're addressing oil production. In California, you have something that is called enhanced oil recovery. The oil that you're trying to pump out of the ground is kind of heavy. So what the producers do is they generate steam. You inject the steam in the ground. You change the viscosity of the oil, and it makes it much easier to pump it out. But they have environmental regulations that are affecting their steam generation processes. And they call them once-through steam generation. Just think of it as a boiler. They generate very large quantities of steam. They burn natural gas. And they have very stiff regulations in terms of the kind of NOx that they have to deliver. So we are working right now with ERA to install our technology and demonstrate that we can meet NOx emissions within the specific regulations or even lower than that. And then we're also addressing refinery process heaters. Like I mentioned, same kind of issues. And if we look at the type of benefits, features and benefits, anytime you deal with combustion, you have to have a very safe type of system. Our system has abides by the highest safety standards. It meets the most strict regulations you can find anywhere in the world. And then what's important, because we can deliver higher heat transfer, and we can operate the system under a wide variety of conditions, we can generate a return on investment. So you don't have to suffer in terms of fuel savings. You don't have to suffer in terms of your production capabilities as well. So the way we look at it, if you have to operate your system without Duplex, this is how you're going to be looking at it. Now, because we're from Seattle, if we operate with Duplex, of course, you're going to have Bill Gates looking at it. So thank you very much. And I just want to mention, we're very happy that we were awarded the New Technology Development of the Year award recently here in Bakersfield. So we're very proud of that recognition. Thank you very much.
And actually, Roberto, in terms of education, forgot to mention that he went to the School of Hard Knocks. Sorry. I had to work on that one. Apologize for that one.